Now we are moving on to graphing. The first graph that you are expected to know how to draw is the stem and leaf plot. So, for example, we could say how many times have people attended the cinema in the past year, and you get the data 6, 2, 13, 1, 4, 8, 11, 3, 4, 16, 7, 20, 13, 5, 15, 3, 12, 9, 26, and 10. So the first thing we kind of should do is, well, we could order the data, but it is just quicker because if you, it will make sense once you see what a stem and leaf plot looks like, just to group it in like the tens digit of it. So we can see here we have a 6 that's in the 0 to 10, 2 is in the 0 to 10, and that 13 is 10 to 20. We've got a 1, 4, 8, 11 here, 3, 4, 16 here, 7, and then the 20 will go down here, 13 here, 5, 15, 3, 12, 9, 26, and 10. So then we'll commence drawing our stem and leaf plot, and the stem and leaf plot, funnily enough, consists of a stem and a leaf. So your stem kind of will look like this, and we write in your 0, a 1, and a 2. Now for the leaves, which probably should do like this, the leaves you'll have, and you need to put it in ascending order, left to right. Put a 1, a 2. We've got 2 3s, so we write them separately. 4, 4, 5, 6, 7, 8, 9, and I'll just extend this bit. So that's the first, so these are your leaves, this is your stem. Well, that's also your stem, that's all the stem. Then, so your second row, we have a 10, so we write a 0. We've got a 1, 2, 3, 3, 10, 11, 12, 13, 13, 15 and 16. Then the last one we got a 20 and a 26. So this graph is not done yet. We must also add a key. We must say that like this, which is like an excerpt of our graph here, means 1 visit in the last year. You have to make it make sense in the context of the question. And you don't have to title it, but in the real world you probably should be titling this. So you would say number of times people attended the cinema in the past year. So that's a simple example. We can do another example that is just a bit different. You could get given 2 sets of data, so which means you'll have to do something called a back-to-back stem and leaf plot. So an example could be total number of eggs laid in the nest of 2 species of bird. And it's recorded over a number of seasons. So given in examples of 10 different nests, so you'd say your the 2 species are your wrens and your dunnocks. And the wrens are given as 22, 18, 21, 23, 17, 23, 20, 19, 24, and 13. Dunnocks are given as 28, 24, 23, 19, 30, 27, 22, 25, 22, and 17. So the first thing, like we did before, now if you noticed, they've only got 1s and 2s in front of them. So in this case, because there aren't actually that many rows, it may be more useful to split them up into rows of width 5. So in this one here, so we'll take our wrens and we'll say, okay, the 22 is in the 20 to 24 row, then the 18 is in the 15 to 19 row, 21's in that one, 23, 17, 23, 20, 19, 24, then 13. And hopefully you can see you're actually seeing a bit more shape already in the data by making the widths a bit smaller. Then for the dunnocks we'll do the same. Start off with a 28, which is in the 25 to 29 row, 24, 23, 19, and then the 30, which is in yet another row on its own. Then 22, 25 belongs in the 25 to 29 row, 2, then we have a 17 here. And hopefully you can see again, you're actually seeing a bit more shape in the data when you split up. And then, so that means when you draw your stem and leaf plot, we have to draw kind of it actually looks more like a stem now when you've got 2 of them. This is going to look a bit more like a tree because it's got 2 sides. Wrens on one side and dunnocks on the other. And then what you would do in your stem, you'd have to write a 1, a 1, a 2, a 2, and a 3. You don't actually have to specify if it's 20 and 25 in the stem because it will be clear in the leaves. So on the wrens, we'll do the wrens first. We have 13 here. And then we have to make sure we're going right to left on the left-hand side. 7, 8, 9, and a 20, a 1, a 2, a 3, a 3, 4. And that's the wrens done. Now the dunnocks. We start here, 7 and 9, then 2, 2, 3, 4, then a 25, 27, 28, and a 30. And don't forget your key. Now you choose one where you actually have both leaves involved. This means 17. Well, that's honestly a poor example because they should be different to actually make it clear the sides you're using. Even though that is written in your graph, you kind of should. This means 20 eggs in a wren's nest and 22 eggs in a dunnock's nest. And you could also add a title. Here is an example of a stem and leaf that we can practice analysing, interpreting. So one of the advantages of a stem and leaf is you can quite easily see the shape. You can quite easily see the shape. So on the girl's side, you can see it's kind of peaking in that lower half of the 90s, right? And it's the same for the boys. So we can see a few things. That tells us for both the modal class is, and we can say it's the modal class without having to calculate frequency density, because we know in a stem and leaf plot, the rows are always of equal width. So we just look at what has the highest frequency. Both, the modal class is 90 to 94. And those are both in percents. That's one thing we can see. And once again, if we look back at that shape, we can see that they are negatively skewed. And this is seen because you've got the tail along the bottom. Most of the marks are high, but a few drag the mean down. And then you can actually find the median for both. So if we have a look at the median for the boys, well, we know that we've got an n of 13, so we do n plus 1, that's 14, divided by 2, 7, so we just count find the seventh number. 1, 2, 3, 4, 5, 6, 7 is 93%. And then for the girls, you've only got 12, so it's going to be between the 6th and the 7th. 1, 2, 3, 4, 5, 6, and 7th, so it's going to be 90.5. And then you could also calculate the mean. So and you just sum up all the values. You would sum up all the values, 82 plus 85 plus 89 plus 90 plus 91 plus 93 plus 93 plus 94 plus 94 plus 95 plus 96 plus 96 plus 99 over 13, and that gives you 90.1% to 3SF. And the mean for girls is 81 plus 84 plus 86 plus 86 plus 88 plus 90 plus 91 plus 92 plus 93 plus 97 plus 97 plus 98, all divided by 12. That equals this is actually, we're going to get a precise mean here, 90.25%. And for the boys, we can see that yes, the mean is slightly lower than the median, and for the girls as well, the mean is below the median, and that shows it is negatively skewed. And we can also look for outliers. These are any extreme values, but there are no outliers here. They're all fairly close together. And we can also look at things like the range. So range for boys, this is your spread. Now we're looking at the spread. Range, boys, 99 minus 82, 17%. Range for girls, 98 minus 81, so that's 17% again. So range is the same. So you may want to look at the interquartile range. So if you find your quartiles, so 13, you know the mean is here, the median, sorry. Cross that out and then try to find the median of the lower side. So it's going to be between these two. So 89.5. And then your upper quartile is going to be 3 between these two, so 95.5. So IQR equals UQ minus LQ equals 95.5 minus 89.5, which is equal to 6%. And for the girls, the LQ is, we split it in half. And then find it. So 1, 2, 3 in here. They're the same number anyway, so it's going to be 86. The UQ is going to be 1, 2, 3. Between these ones, 93 and 97, which is 95. Equals UQ minus LQ equals 95 minus 86 equals 9%. So because of the interquartile range, which generally tells you a bit better of a story about the spread, I'd say the girls are more spread out. You could also do the standard deviation, but that would take some time, and so we will not bother at this stage.